We're going to talk about parabolas today. They are a type of conic section. We're going to add in the parabolas that open either left or right. So let's just jump in. We already know a lot about parabolas. We'll be able to, I think, get these pretty quickly. So if you take a look at our first example, y equals the quantity of x minus 2 squared plus 3, the standard form or the vertex form, you might recall, look like that. Y equals a times the quantity of x minus h squared plus k. So that's a good thing to know. We learned that before when we dealt with parabolas. The vertex is hk. The a tells us if it's opening up or down. If it's positive, it goes up. If it's negative, it goes down. And it has a symmetry to it. We know about parabolas. So in this particular case, our A is 1, so it's opening up. We know that our HK, or our vertex, is 2, 3. Now remember, for that to work, this one is going to change sign. This one does not. You see how this one is the opposite of H. This one is K. Okay. And then for parabolas, we are going to make a table. We're going to put our vertex in the middle, and then we're going to plug in one above it and one below it. So in this case, since my vertex is at 2, 3, I'm going to plug in 1 and I'm going to plug in 3. Now, when I plug in 1 into the original, I get the quantity of -1 squared, which is 1, plus 3 is 4. Now, you know that you've picked the correct vertex and that you plugged it in right. If when we plug in 3, we get 4 again. So if I plug 3 in right there, I'm going to get 3 minus 2 squared, which is 1. Squared is 1. Plus 3 is 4 again. So that's a really good way to kind of check your work. So then graphing it is pretty straightforward. We're going to go over to 1, 4, 2, 3, and 3, 4. If we happen to plug in 0, we do get 7. So that's sometimes a nice thing to plug in. I didn't ask you for the y-intercept, but it does kind of give us more information. Yes. Yes, you can. Yeah. And so there is our parabola. Remember, it does have an axis of symmetry through the vertex. You know, you can see, you should have expected that it is a parabola opening up. If there was a negative right there, that would have just flipped it, but everything else kind of would have stayed the same vertex, except these ones would have gone down instead of up. Any questions about example 1A? Okay. So for the very first time in this class, we're going to look at one that starts out with x equals. So a parabola that is a function that opens up or down always is y equals x squared, some combination of those things, y equals x squared. If it's x equals y squared, it opens up left or right. So let me show you the kind of the general vertex form for B. So for B, the general form is x equals a times y minus k squared plus h. Our vertex is still hk, but you might notice something happened. Our h is out here because it kind of goes with the x. our k is inside by the y. We've learned kind of from earlier section circles yesterday when we were doing hyperbolas. Basically, we've learned that if it's by the x, it's pertaining to the x. If it's by the y, it's pertaining to the y. So it's by the y here. So that is the vertex's y. And that one is the one that changes sign this time. If A is positive, it's not going to open up. It is going to open to the right. If A is negative, it's going to open to the left. So that's what the A does here. It flips it on its side. So these are laying on their sides. So then let's pull out the information that we have about this particular parabola. Our A is 1 because we don't see it. That's a positive number. So we should expect that it opens to the right. So when I say open to the right, it looks like this. So a parabola lying on its right side. Our vertex is still HK, but remember, the H is out here, the K is inside because it's by the Y. So our vertex is negative 2, 1. Our vertex is negative 2, 1. Now we're still going to make a table, but here's another interesting thing. We still have a vertex of negative 2, 1. I'm going to put that in the middle of my chart. But this time, we are going to plug in y's. This is not a function. It is a function of y, not a function of x, like we're used to. So we have to plug in y's. So if we plug in y's, we want to plug in a y that is 1 above and 1 below, just like before. So I'm going to plug in 0 and 2. But I have to plug in y's, and I'm going to put my y right there. If I plug in 0 right here, I get negative 1. When I square it, I get 1. 1 minus 2 is negative 1. Now, just like a parabola that's going up and down has symmetry, a parabola that's lying on its side, it's got symmetry. And so I should get negative 1 again, but let's try it out, make sure. I'm going to put 2 in right there. I get 2 minus 1, which is 1. When I square that, I get 1 minus 2. Guess what? It's negative 1 again. So you still kind of get the same exact kind of symmetry, but it's laying on its side. It's the symmetry now goes through a vertex, and it is a horizontal line instead of a vertical line. Now let's go ahead and plug those points on our graph paper, and I'll show you kind of what to look for. If you plug in or at negative 1, an x value of negative 1, we are at 0. At an x value of negative 2, we are at 1. And here's why it's not a function. If I plugged in negative 1, I also got 2. So the line of symmetry still goes through the vertex, but it's technically a horizontal line. And then let's plug in, if you plug in, if I plugged in an x value of 0, or a y value, I'm sorry, if I plugged in a y value of, well, it goes like this. We'll just have to guesstimate for now. I believe that these points here are like from a square root, so you don't get anything nice. Anyway, so if it's in vertex form and it starts out x equals y squared, we should expect a parabola lying on its left or right side. So that is the difference that we're going to see for example 1. Do we have any questions about example 1A or B? Now, you might recall that not all parabolas like this looked like that. So we are going to come across some that we have to fix the problem. We have to do some other things. And that's what leads us to parabolas in standard form. So this is standard form. And when it is in standard form, to find the vertexes x for this one, the x of our vertex, remember that's the h, is going to be negative b over 2a. Okay, so our a is 1, our b is negative 6. So let's go ahead and plug those values into the formula for our vertexes x. So negative b over 2a. I always think of negative b as being the opposite of b. So we have a negative 6 sitting there. So the opposite of that is positive 6. And then I usually do two a's in my head. A is 1, double that, get 2. And so our vertexes x is 3. Now, to find a y value that matches an x value, you just got to plug it in. So our y value, which is our k, we're just going to plug in 3. So it's going to be 3 squared minus 6 times 3 plus 5. Now, please follow order of operations when you do that. So that's 9 minus 18 plus 5. 9 minus 18 is negative 9 plus 5 is negative 4. So that is negative 4. So our vertex we just found is 3, negative 4. Now let's think for a moment when we found the vertex in the last example. Less work. We just got to look at it and go, oh, that's our vertex. So here we had to do a little bit of work to find our vertex. But once we found our vertex, we made a table. So let's make a table again. Because it starts out y equals x squared, we plug in x's to those. So because of the symmetry of a parabola, let's plug in something below that x and above that x. So I'm going to plug in 2 and 4. If I plug in 2 and 4, I should get the same value both times because of symmetry. Okay. So let's plug in 2. If I plug in 2, I get 2 squared minus 6 times 2 plus 5. 4 minus 12 is negative 8, plus 5 is negative 3. Now I should expect when I plug in 4, I should get the same value of negative 3. If I don't, I'm wrong, something's wrong. Okay, so let's plug in 4. 4 squared is 16. 6 times 4 is 24. 16 minus 24 is negative 8, plus 5 is, oh, guess what, negative 3. So that kind of verifies that all the things we thought, our vertex has to be right then, our two surrounding values are right, we are good to go. Okay. So we're going to go over here to 2, negative 3, 3, negative 4, 4, negative 3. We could put our line of symmetry on there. Sometimes that's helpful to see that. If you plug in 0, you do get 5. So if that helps you to find a few more points, you can do that. I like to kind of see where I'm hitting the y-axis. You don't have to have that on there, but it's helpful. So again, because it was y equals x squared, it's the same stuff we have done before. Our vertex is negative b over 2a. We find the x value and then plug it in to find the y value. We do two surrounding x values to find that symmetry to make our parabola. Everybody okay with example 2a? Any questions at all? Okay, so that should be pretty familiar to you. So now let's take a look at why b, which is x equals a y squared. So we should expect that this one is going to open up to the right. It should be a different shape than before. Now we know it opens up to the right because of the fact that it's a x equals y squared. If I didn't put in it, I should have. If there is a negative on the y squared, it would open up to the left. It would flip it, just like we've done before. Okay. Now, we're still going to do negative b over 2a, but this time it gives us the y of our, it gives us the k. So that's going to give us the y value of our vertex. So it just flip-flops. In the first one, it gave us the x, and this one, it gives us our y. We still find the a and b the same way. This is our a, 1. This is our b, negative 2. So we still find the a is on our y squared, the b is on our y. Okay. So let's plug that in to our negative b over 2a formula. The opposite of negative 2 is what we're looking for the top there. That's 2. 2a's is 2. 2 divided by 2 is 1. Okay. So that's our k. So now how could we find our h? Well, we just got to plug it in. So that's going to be 1 squared minus 2 times 1 minus 15. That is going to be negative 16. Sorry, my graph paper is not going to be very good for this one, but we'll figure it out. Okay, so our vertex for this one, the first value we found was the y, not the x, the y. And then the x you have to find by plugging it in. So we're still going to make a table. We still are going to use the point negative 16, 1, except this time you got to plug in y's because our equation is x equals the y's. So you got to plug in y's. Plug in a y above that and below that. So let's plug in 0 and 2. If you plug in 0, you get negative 15. So I would expect if I plug in 2, I should get negative 15. Well, 4 minus 15, negative 15. So I picked right. I did good, okay? So now you got your points. So now we're ready to graph this. An x value of negative 15 isn't on our chart. So here we're gonna fudge it a little bit. Let's call this negative 10. Wait, let's see here. Yeah, I think we might have to do that. Yeah, except then 16 becomes weird. Let's count by 2's. So negative, let's make this negative 2. So this would be negative 10. And this would be negative, or I'm sorry, that would be positive 10 and positive 20 last I checked. So we'll make that 10. We're just going to double everything. Okay. But we can leave our y's. We'll leave our y's the way they are. Okay. So our first point is negative 15, 2. So if we count by 2's, 2, 4, 6, 8, 10, 12, 14. 15 is smack dab in the middle of 14 and 16. So 15 is right here. So at negative 15, we are at 0. And at negative 15, we are at 2. And then at negative 16, we are at 1. And then it looks something like that. I believe the y-intercepts are negative 3 and 5. I almost hit them. Here, wait, let's make this a little prettier. I do hit the points 5 and negative 3. Those are our y-intercepts. Just to make it a little better. If you did what I did initially, you're fine. So that is parabolas kind of in a nutshell there. And if you take a look, there are only 4 of them. 2 of them that open up or down, 2 of them that open left or right. Okay, so if we take a look, this one should open up, this one should open down, this one will open to the right, this one will open to the left.